Good morning, March 26th. I'm going to talk through these notes on sections 3.3 and 3.4 and 3.5 so that hopefully you can understand a little bit better. 3.3 starts with this concept that the cell is semi-permeable or selectively permeable, meaning that only certain things can squeeze between the phospholipids, the individual phospholipids that make up the cell membrane. Building on that, we have section 3.4, diffusion and osmosis, which both are passive transport, meaning no energy is needed to move the molecules across the membrane. For example, this is a concentration gradient. So the highest concentration of molecules will always flow to an area where there's less molecules. This does not require energy. Think of you on your bike at the top of a hill, going down the hill, coasting, not requiring energy. The molecules will spread from a high concentration to a low until equilibrium occurs, until the molecules are evenly distributed. Now, diffusion is a special type of passive transport. The molecules move from high to low. For example, sugar, oxygen, and carbon dioxide move in and out of a cell based on a concentration gradient through the cell membrane. Osmosis is the movement of water molecules only. For example, red blood cell has 0.9% solute and 99.1% water. When you compare this to pure water, the cell is hypertonic, which means it has more solute, 0.9%, than the water, which has 0% solute in it, which is solutes, other dissolved particles in the cell. The rule is that water always moves from an area that's hypotonic, which means it has less solute, more water, to an area that is hypertonic. Hypertonic is more solute. I think this is the trickiest thing. So if you could wire it up in your head like this, if you can't think about it logically the other way, this may help you. So in this case, if you put this red blood cell in pure water, there's more water here than in the cell. This is 100%, this is 91. Water's going to rush into the cell, and if it happens quick enough, it will pop the red blood cell. There are some videos on water intoxication that I'll send you tomorrow where exactly this happens. People drink too much water and they become brain dead because the cells in their brain expand, causing their brain to die. And we'll talk more about that tomorrow, water intoxication. Now, as I go to the next section, section 7, facilitated diffusion is also passive transport of molecules, no energy needed. A transport protein is needed to let larger molecules in. For example, from your textbook, there's the transport protein still going from high to low. And you can see the molecule is very large. It needs to get in to the inside of the cell. Sugar is one example of this. And here's where insulin plays in, because insulin is a protein that is used as a receptor to help the sugar find the cell to get in. That's why if you have diabetes, you can't get the sugar into the cell because the little guy waving, here I am, isn't there. That's insulin's role. Okay, section 3.5. Active transport requires energy to move molecules against a gradient. So here we're going from a low concentration of molecules to a high. Picture pushing your bike uphill. That's going to cost energy, and the cell will provide that energy. Your diagram in your book has the concentration low going through this protein pump to a high concentration. This type of transport will be discussed mucho in Chapter 4. Protein pumps are used to move molecules from low to high. Those brackets mean concentration. Lastly, exo and endocytosis is moving really large molecules like food in and out of a cell by using a vesicle. In the videos I sent you, amoeba will engulf or phagocytize, phagocytosis, taking in endocytosis, but phagocytosis is a special type of endocytosis where large molecules like food are moved into the cell and put in a vesicle, then digested. Exocytosis is when molecules that are large are released. For this, I sent you the mouse party, and it shows how dopamine and serotonin are released into the synapse of nerve cells by the process of exocytosis, and that's what creates the effect of the high in drug use. So I hope this helps you. Tomorrow we will continue.